In this video, we're going to try and understand the domain and the range of this function f of x equals square root of x. So I'm expecting you to know that the graph looks like this. So the domain of this function is what you can put into the machine, this machine here, without it breaking down. So for example, when you put 4 into this machine, it will square root it and it will spit out the number 4, the number 2. So when you input the 4 into the machine, it will spit out a 2. So this is 2, not to scale. And then if you put a 25 in here, it will square root it to spit out the number 5. So domain is what you can put into the machine without the machine breaking down. So if you look at -9, you see -9 is not in the domain, because if you try and put -9 into the machine, put -9 into the machine, it's like me asking you to square root a negative number. What is the square root of -9? Well, you could say, oh, the square root of -9 is, you could guess it's -3. But then -3 times -3 gives you a +9, because 2 negatives. You see, as far as you're concerned, you can't really square root a negative number. So that's why the square root graph, there's nothing on the negative side. So -9 is not in the domain. Your domain is what you can put into the machine without the machine breaking down. For example, you can actually put 0 into the machine. You can actually put 0 into the machine. 0 is right at the origin. Square root of 0 is 0, so we spit out the number 0. You see, 0 is in the domain. So when you come to write domain, there are lots of ways of writing domain. It depends on your teacher. So one way is to write domain. The domain of this function would be ... X belongs to, so this is just an epsilon sign to depict that x belongs to the real number line. Now let me explain this thing here. The number line, when you're under 16 years old, as far as you're concerned, the number line will look like this: 1, 2, 3, 4, and so on. -1, -2. So this is the number line that you're familiar with. When you reach about 16, there are these numbers called complex numbers. So there's I, 2i, -i, and so on. You see, this here is a number. This here is a complex number. This number is 3 plus 2i. This collectively is a number. That is a number. So you can't, by me writing this, x must be on the real number line. It means that you can't put a complex number into the machine. If you put a complex number into this machine, the machine will break down. So by me making this statement, it says that you can put anything into this machine so long as you live on the real number line. Don't go putting a complex number in there, otherwise the machine will break down. So x belongs to anything on the real number line, comma, and then you have to state a further rule that x must be greater or equal to hang on. So you have to state it as x being greater or equal to 0, because it can be 0. You see, by me making this statement, it's saying that don't put any negative numbers in there, like -9. Don't put -9 into there, it will break down. So x must be bigger or equal to 0. So that's your domain. Now range, when it comes to range, your range, if you look at the number that it spits out, it can spit out the number 0, where square root of 4 is 2, square root of 25 is 5. Let's imagine this is 25 here. It spits out 5. It spits out 5. You see, the number that is the numbers that the machine spits out will never be a negative number. Look at the graph; it will never be a negative number. This machine will never spit out a negative number like a -3. It will never spit this out. It will only spit out numbers greater than 0. So the range ... the range would be y will be bigger or equal to 0. So this is your range. Range is the scope at which the numbers are being spat out. So it must be bigger than 0. Okay, so this is your range and this is your domain.